Let's take a look at the other triangles we have. In problems 3 and 4, we had this triangle where the side opposite theta was 6 feet and the hypotenuse was 10 feet. And this was a right triangle. Those are the three pieces of information that you're given. Since we're looking at opposite and hypotenuse and I want the angle, I have to use side. If the first thing I went for was the adjacent side, then we might be leading with the Pythagorean theorem. But since I asked for the angle first, we have to use sine because I've only got opposite and hypotenuse. So we'll do a sine inverse of 6 over 10. Once again, we're doing a sine inverse because we are trying to find an angle. Sine inverse of 6 over 10 is 36.9 degrees. Once we have the 36.9 degrees, we have options for finding the side adjacent. So if I want the adjacent side, I could use the Pythagorean theorem, which seems like the best choice. I think the Pythagorean theorem would be the best choice here because the 6 and the 10 are both given, and this 36.9 is rounded off. So most likely for the hypotenuse, oops, I have the hypotenuse. Most likely for the adjacent side, I'll just use the Pythagorean theorem. And that'll be the square root of hypotenuse squared minus opposite squared. I can grab my calculating machine and ask for the square root of 10 squared minus 6 squared. And that'll give me the 8. Any questions? Same thing happens over in 5. Same kind of decisions we're making over in 5. I'm looking for theta. I have the adjacent side on the hypotenuse. That tells us that we should use cosine. So we're going to do cosine inverse since we're looking for an angle. I need the cosine inverse of 12 over 15. And I get a 36.9 again. So we got the same value of theta in the problem 5 that we got in problem 3. If I look at the side opposite theta and use the Pythagorean theorem to find that, we'll see why this angle showed up as the same. So now I'm looking for opposites. That's going to be the square roots of 10 squared, or 15 squared. Minus 12 squared. So what we want to notice about these two particular triangles, it wasn't one of the problems that we had to notice, where we had to notice this, but one of the things that we want to notice about this is that these two triangles are similar triangles. The triangle in 5 just has bigger numbers. The triangle in 3 is actually much bigger because it's in feet, and the triangle in 5 is in centimeters. But the numbers are all bigger. The ratio of the sides is going to be the same. The ratio, so we got 9 centimeters over here. And down here we got 8 feet. The ratio of the sides in similar triangles will always be the same. These triangles are similar. Similar triangles have all the same angles. And the sides are all in the same ratio. The sides aren't going to all be the same because the triangles aren't equal. The sides are in the same ratio. So the ratio of in the third triangle is 6 to 8 to 10. That's the same ratio as 9 to 12 to 15. If I take 6, 8, 10 and divide everything by 2, I get 3, 4, 5. If I take 9, 12, 15 and divide everything by 3, I get 3, 4, 5. So in any pair, the ratio will be the same. So that will make, and since trig functions give us ratios, that's why, and we have the same angles. Any questions? How's everybody okay? We look so very. This is for any triangle. In any triangle, the angles, when the angles are all equal, the sides will be in the same ratio. This shows up on your homework with some non-right triangles. We just happen to be playing the right triangles game, so I took the opportunity. How's everybody okay? Are you sure? So everybody looks so very sad. So I have a very important question. Why do people think Thanos was so smart? I mean, what an idiot. I mean, he could do like anything he wants, right? Once he has the Infinity Gauntlet. And he's like, oh, I'm going to get rid of half the population. And you're like, well, why are you going to do that, Thanos? Because using too much resources. It's like, well, why don't you make some more resources? Dumbass. Well, then with the population just get bigger, well, then why don't you teach us to use our resources better? I think we all know the real answer. He wanted to dust half the universe. So I want to dust half the universe. That sounds like a bad plan. I want to save the sentient species. Yeah, that's it. It's a resource thing. Yeah. Those are your only two options. Either really stupid or just like incredibly, incredibly mean. What are we talking about? Oh. I thought about that because YouTube showed up when I was putting videos up on YouTube. And there's an edit of Walter White in the Avengers. I'm like, what the hell is going on? The AI is going to come up with some really weird shit. The AI is going to like, oh, do you like Breaking Bad plus Avengers? All right, then. All right, let's take a look at oops, I don't want this one. You have that. I want this one. One of the things that's going to come up, so the next thing we need to talk about is the homework situation. If you click on one of the homework assignments with Wiley Plus, it will take you to a page asking you for a registration code. You are not supposed to need a registration code. You don't have to buy anything. It's supposed to be included. This class is inclusive access, so you don't need any more codes to register. It's supposed to just take you there. And it didn't, for the most part. So I have contacted Wiley Plus and said, this is inclusive access. We need the inclusive access stuff. So as far my understanding is, there's a setting on their end where they need to change it, and then you'll gain access. So you might just have to wait to get the homework assignment stuff. I know there are homework assignments that are due today. You're just gonna have to wait to get those done. I know the guy that decides when the homework assignments are due, and I'm pretty sure he'll move them for us. He's kind of a dick, but I could probably talk him into it. So don't worry about that. Don't worry about the due dates. I'm not going to go in and change them until I know that we all have access. Because if I change them to like Friday or something, then Wiley will be like, oh, we'll have it changed on Monday. Then I have to go and change them again. So I'm just going to wait. So if you didn't have, as soon as you didn't, if you did not have access before, when you get access, I just need one of this to let me know. So the condition is you did not have access to Wiley Plus, and now you do have access to Wiley Plus to say, let me know, I didn't have access before, I do have access now. It needs to be one of you. Actually, forget that. It needs to be everybody for which that is true. Otherwise, nobody will do it. Because you'll be like, oh, someone will take care of it. I don't have to say it. I'll be like, oh, shit, it's still not working. And then everybody will have done the homework. Any questions? Comments? So typical school solution, right? So, oh, if it applies, it needs to apply to one, we'll make it apply to everybody. That's these schools, everybody got to suffer rule. All right. So one of the things that comes up in our homework is the different ways we measure parts of a degree. So one of the ways we measure parts of a degree is just with decimals. We can have things like 36.9 degrees. So we can have decimal parts of degree. But another way that we measure angles is in degrees, minutes, and seconds. So rather than using decimals, we decide that we want to use fractions because everybody loves fractions. Especially when the denominator is 60. That's our favorite denominator. We all love the 60, especially when we can move it up into a 360. That's why we need to move the Earth closer to the sun by 5 days so that the year will be exactly 360. Because 360 is a great number. It's divisible by so many things. So anyway, we have another, this is the other way that we measure degrees with degrees, minutes, and seconds. That's how we measure parts of the degree. 1 degree is 60 minutes. 1 minute is 60 seconds. So what that means is that 1 degree is 60 minutes times 60 seconds, or 3,600 seconds. So I'm just going to pick one in the middle. We need to be able to convert from one to the other. So we need to be able to convert from degrees, minutes, seconds to decimal degrees, and from decimal degrees to degrees, minutes, and seconds. So let's talk about doing that. So if I have the angle that measures 14 degrees, 7 minutes, and 26 seconds, there are 60 minutes in 1 degree. So that 7 represents a fraction. The nice thing is we have fancy calculators, so I can just put 14. 7 minutes is 7/60ths of a degree. So the 14 represents degrees. 7 minutes represents 7/60ths of a degree. 26 seconds is 26 over 3,600 degrees. Take the 26 and divide it by 3,600 degrees. All we're going to do is take these three fractions and add them together. To do that, we need a common denominator. That's what we're doing here. It's the same thing that we always do when our units are different. Addition says we only add things that are the same, and when we add them, it doesn't change what they are. In this case, I want everything to look like degrees. 7 minutes is 7/60ths of a degree. 26 seconds is 26 3600ths of a degree. Then I can just grab my calculating machine and be all, hey, calculator, what is 14 and 7/60ths and 26 3600ths? And we get 14.123, a bunch of 8s and a 9. It's probably 8s all the way down after that. So we just wanted to read degrees, minutes as fractions of a degree over 60, and seconds as fractions of a degree over 3,600. Any questions? Going the other direction, we have to look at the decimal part and figure out what the fraction is. So let's grab another one of the other ones. So I'm just going to pick one. So let's suppose that we have 105.2347 degrees. So the first thing is 105 of those are just degrees. So we start off with 105 degrees. So what I'm going to do is it's the fraction part that I need to fix. So I'm going to take the 105.2347 and I'm going to get rid of the 105 degrees because I care about the fraction. I'm just going to look at that 0.2347. This is the same kind of ratio stuff we were doing on Monday. It's 0.2347 over 1, and I want to convert that into something over 60. So the point I'm looking at 0.2347 over 1 is what over 60? This is not necessarily what we're going to be writing down. This is how we're going to be thinking. We're thinking 0.2347 over 1 is something over 60. To figure out what the x is, I need to multiply by 60. Just take the 0.2347 and multiply by 60. And that's going to be 14.082. That 0.082 is 0.082 minutes. I want to convert that into seconds. It's 0.082 over 1. I want to convert it into seconds. I just want to make the denominator 60. I'm only going to use 60 and not 3,600 because it's 0.082 minutes, not 0.82 degrees. So 0.082, I'm going to multiply the 0.082 by 60. So I'm going to get rid of the 14 and multiply by 60 to get 4.92 seconds. The instruction said to round to the nearest second. So it's 105 degrees, 14 minutes, and 5 seconds. The instruction said to round to the nearest second, so the 4.92 becomes 5. Take off the whole number parts. These proportions for the numerator. The calculator can also do this for reasons. The reason I think that the calculator's functionality is that I don't remember where it is. But it'll be there. You could probably also put it in Google and have Google do the calculator for you, because the Google search bar is also a calculator. Any questions? Comment? All right. That's going to do it for today. That's going to do it for this week. Once again, if you did not have access to register to Wiley Plus before and you gain access, so check again tomorrow. You have gained access to Wiley Plus, please send me an email saying I got into Wiley Plus when I put it forward. I appreciate that. That's going to do it for today. That's going to do it for this week. I'll see you all on Monday. Everybody have a good weekend. And thanks for playing.